days less time than it takes his son to build a garage. If they work together, they can do it in 1/3 the time it takes the son. How long would it take each alone? All right. So the typical problem is it's 1 over the person one's time plus 1 over person two's time equals 1 over their together time. That's generally the recipe here. So it looks like the son, let's call this the son, the parent, and then I guess together. Okay. So the parent can do it in 6 days less than it takes his son. So that's t minus 6.
Okay.
The son takes t times to do it. The parent is t minus 6. And together they can do it in 1/3 the time of the son, which is t.
Fair.
So now notice there's only one variable in this equation, which means that it can be reasonably solved here. One of the things is, first thing I'm going to do is move this 1/3 up. So this becomes 3 over t, 1 over t minus 6, and this is 1 over t plus that. Now, one of the nice things here is because these are both t, you can just subtract 1 over t from both sides. You don't have to do any weird things here. So it's 1 over t minus 6 equals 2 over t. All right, and then you can just cross multiply here. So you get t equals 2 times t minus 6, t equals 2t minus 12. Subtract t from both sides, add 12 to both sides, and you get t equals 12. So 12 days. So t is the son. The father is t minus 6. So that's 12 minus 6, which is 6 days for the father. Any questions on that?
Actually, no.
This one's pretty straightforward because of this thing. It's usually written like this: 1 over t1 plus 1 over t2 equals 1 over t together. And so this one's kind of a straightforward one of that, surprisingly, of all the ones we've done. All right, so 10.
Actually, we can go on to number 11.
Number 11.
Class.
Great. All right, A train leaves A for B, 264 miles distance at 9 a.m. And 1 hour later, A train leaves B for A, and they meet at noon. Okay, so here's A, here's B, and they're 264 miles apart. And train A leaves at 9, and 3 hours later, they meet somewhere in the middle. So the distance that A travels is some rate, but it goes for 3 hours. Rate of A goes for 3 hours.
All right,
now,
clear.
Yep, okay. Now, the distance B is the rate of B, but only goes for 2 hours because it leaves at 10. And what we know is that distance A plus distance B equals 264. So 264 is equal to 3 r sub A plus 2 r sub B. So that's like one of our equations we're going to use.
Okay.
All right, now, if the second train had left at 9 a.m., okay, so the second train and the first at 10:15 a.m., they would have also met at noon. Okay, so the next scenario is that distance B here, because that's the one that goes first. It has rate B, but it went 3 hours. Okay, and then distance A, it has a rate of A, but it went an hour and 45 minutes. So we would call that 1 3/4 or 7/4 hours.
Okay.
All right, so same thing again, when you add them together, 264 equals 3. Let me do it in the right order. It's 7/4 RA plus 3 RB. Okay, so you have these two equations and two unknowns, basically.
Right.
Anything unclear about that?
No.
Okay, so on this one on the right here, so this is brutal. These are just not, I mean, there's a reason they don't make them like this anymore. They're just hard to do. All right, so we're going to multiply the second equation by -2 and the first equation by 3 because we want to clear that one out. That seems to be the most reasonable one. 3 times 264. Even I would get caught up on some of this stuff because it just takes too long. So that's 792 equals 9 RA plus 6 RB. And then this -2 times 264. And this is where you gotta be really careful because you get the wrong number here. You know, everything else gets screwed up. So it's -528 equals minus 7/2 RA minus 6 RB. And when you add these together, it works out. So this is 264 equals 9 is like 18/2. So when you add up this way, you get 11/2 RA. And then you multiply both sides by 2/11. I can't even believe this is going to work. 264 times 2/11. It does. RA is 48. I cannot believe that, but it does work. Okay, so then to find RB, you can use any number of equations. This first one kind of looks nice. Let me grab it. Go scroll down here. So you go find an equation you like. And 264 equals 3 times 48 plus 2 times RB. So 3 times 48 is 144. 264 equals that plus 2 RB. Subtract, you get 120 equals 2 RB. So RB equals 60. And that's the two things it's asking for, and that's miles per hour, miles per hour. So maybe the only like thing that we can say that's really positive here is that your answers should be nice, which means that like if you get something that isn't nice, you made a mistake. Maybe you can go back and look for it.
All right.
So I'm gonna move to question 12 here.
Yeah.
All right, if 5 men and 2 boys work together, piece of work can be completed in 1 day. If 3 men and 6 boys work together, it can also be completed in 1 day. How long would it take a boy alone to do the work? All right. How do we do these? So the men have a rate and the boys have a rate.
Yeah.
So 5 times the men having their rate plus 2 times the boy having their rate equals a job being done.
Okay.
And 3 men and 6B, it can also be done. I feel like this isn't right, but let's go with it for the moment here and see if we can get it. So if we multiply the top one times -3, we get minus 15m minus 6b equals -3. And we add, so we get minus 12m equals -2. So m equals 1/6. So each man can do 1/6 of the job. That's what that means.
All right.
So the boys, now we got to go back and grab one of the equations here. So let's go to, let's grab this second one. So 3m plus 6b equals 1. 3 times 1/6 plus 6b equals 1. 3 times 1/6 is 1/2 plus 6b equals 1. So 6b equals 1/2. Divide both sides by 6, and b equals 1/12. So a boy can do 1/12 of the job. And that's what they're asking here. How long would it take a boy alone to do the work? So each boy can do 1/12 of the job in a day.
All right.
So that means that it would take a boy 12 days to do it. Because every day they can only do 1/12 of it.
Well, I guess that's it. I don't know what to do with the remainder of the time.
It's up to you. You know what? Look, so you scheduled, yeah, we didn't kind of use it all up. When do you want to do another lesson? Are you going to need one tomorrow night?
Most likely.
All right, so let me do this for you. Let me just put you down for tomorrow night. Let me see what's available. And it'll just be a courtesy to you since you've already scheduled a bunch of appointments. So let me just take a look here. Is 8 o'clock okay again? 8 o'clock Arizona,
Yeah.
I don't know.
8 o'clock. Great. Thank you so much.
Okay, I'll send that to you. Let me do that right now. Actually, that will be the actually, you know what, the easiest thing for me to do is to just move the one we just did to tomorrow.
All right.
And so just use this
Yeah.
which one do I want to do? No, let me just do it right now. Okay, I just need a few pieces of information from you. I'll do it right now. Come on, chugga, 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 chugga. Okay, let's see here. We got scrolling. Okay, 8 p.m. tomorrow. All right, Jack Putnam. What email would you like me to use? Can you spell it for me?
What's my what?
What email should I send this to?
Oh, the Jackie Putnam at gmail.com.
Jackie Putnam at gmail.com. I do need a phone number, just real quick, 520
244
244
43.
4390.
Yes.
Okay. All right. You're all scheduled for tomorrow. There's no charge on that. And thanks again. I'll send you the notes and the screen recording out shortly.
Excellent. Thank you so much.
You're welcome. See you
Bye-bye.
tomorrow. Good night.